In this video, we will work with more complicated expressions, continuing to use the distributive property and combining like terms to simplify them. We will also solve a couple of real-world problems. So we're stepping up our game. So there are some quick things that we should review. One is what an exponent is. An exponent tells us how many times to multiply an expression by itself. So if I have x cubed, that means that I'm going to multiply x by itself 3 times. Okay. If I have something in parentheses that is being raised to a power, that means that that whole thing in parentheses is going to multiply by itself. Not so important for us at this moment in time, but it will be crucial for us later in the year. Okay? So when you're multiplying x by itself, we get x squared. And when we multiply x by multiple things, we use the same distributive property that we learned in the last lesson. X times x will be x squared, and then x times 4 will be 4x. Okay. So, exponents reviewed. Now we're going to review a couple of our integer rules. An even number of negatives multiplied together will always end up positive. Remember that our even numbers are 2, 4, 6, 8. So if I have 2 negatives and I multiply them together, my answer will be positive. If I have 4 negatives and I multiply them together, my answer will be positive. Okay? So if an even number of negatives multiplied together gives us a positive, then an odd number of negatives multiplied together will always end up negative. Okay? So I know that if I have negative 2 times 3, I only have 1 negative, my answer is going to be negative. Okay? Division works the same way. Dividing by an even number of negatives will give you a positive result. Dividing by an odd number of negatives will give you a negative result. All right, adding and subtracting integers. These are the harder rules for people to remember. Okay. If the signs are the same, we add the digits together, but you keep the sign that you had. 3 plus 5. We've been doing 3 plus 5 since we were in elementary school. Nothing changes. It's 8. Negative 3 minus 5 is the same thing as negative 3 plus negative 5. We're going to add the digits together. 3 plus 5 is 8. And we keep the negative sign. If the sign are different, we're going to subtract the digits and then keep the sign of the larger digit. Okay? That means the digit that has the higher absolute value. So in this example, I'm going to subtract 5 and 3. 5 minus 3 is 2. Now, which digit is higher or larger? 5, because 5 is bigger than 3. Since 5 is positive, my answer is positive. In this example, again, I subtract the digits. 5 minus 3 is 2. But this time, the 5 is negative. So my answer is negative. Okay? This last idea is probably one of the most important, and we use it a lot, especially when we get to solving equations next week. A positive and a negative of the same digit cancel each other out. So negative 3 plus positive 3 will give us 0. Okay? But if you have the same digit and they have the same sign, they will not cancel out. Negative 3 minus 3, we need to go back to that first rule. Those signs are the same, so I add my digits together and I keep the negative sign. All right, so let's get started with some examples for our algebra. We're going to take this negative 8 and we're going to distribute it to 5r plus 1. So negative 8 is going to multiply 5r to give me negative 40r. Then I'm going to do negative 8 times positive 1. Negative 8 times positive 1 is going to be negative 8. So here is my simplified expression. Okay? Just to see the work done out. Okay, we are distributing that negative 8 to both pieces. In this example, I've got a distributive property with division. I can take n squared and divide it by n. And I can also take negative 5n and divide it by n. So I've got n squared divided by n minus 5n divided by n. Now if I have two n's on the top and one n on the bottom, the n's will cancel out, leaving me with just n for this piece. I've got an n on the top and the bottom. Those n's will cancel out, leaving me with just 5. Okay? In this example, which is probably one of the trickiest ones that we've got, I've got a set of parentheses with two different terms in it. That is a big red flag that I'm going to have distributive property, but there's no number in front. Well, actually there is. We don't write it. The invisible number in front of a set of parentheses, if there is nothing there, is 1. So in this case, we've got to distribute negative 1 to x and to negative 5. Negative 1 times x and negative 1 times negative 5. So expanding this out will give me negative 1x plus 5. Then I bring down the negative 4x that I had in front and the plus 5x that I had on the back. Here are my like terms, negative 4x, negative 1x, and 5x. Negative 4x minus 1x will give me negative 5x. Then I can combine these negative 5x plus positive 5x to give me 0x. And anything times 0 is just 0. So my simplified expression is just 5. Okay? All right, yet another example. Holy bejesus, there are some fractions. What are we going to do? Well, the first thing you're going to do is you've got two sets of parentheses. So I'm going to work those one at a time. This first set of parentheses has a 2x in front of it. So I'm going to multiply 2x and x together. 2x times x gives me 2x squared. Then I'm going to do 2x times negative y. Negative 2xy. Okay? We can't combine x and y to make one thing. Over here, I've got negative 1/3 y that's got to multiply 6 and negative 15x. So, 1 divided by 3. Did you hear what I just said? 1 divided by 3. The fraction bar means division. Okay? So what this really means over here is that I've got negative 1/3 y times 6. Well, that's the same thing as negative y times 6 divided by 3. And I know what 6 divided by 3 is. It's going to give me negative 2y. Okay. Then over here, I've got negative 15x times negative 1/3 y. So what I really have is a negative times a negative, which will give me a positive. 15x y divided by 3. And 15 divided by 3 is 5. Okay. So I had these two pieces over here. Here's term 1. Here's term 2. Here's term 3. Here's term 4. So I'm going to rewrite things with my like terms next to each other. I don't have anything that can combine with 2x squared. Then I've got negative 2xy. And I've got a positive 5xy. And then I've got a minus 2y. Okay. The only things that can combine together are these two terms in the middle. So my final expression is 2x squared plus 3xy minus 2y. All right? All right, last but not least, word problems. You and two friends all have the same meal for lunch. Each meal costs $C plus a tax of 6% of the cost and a tip of 20% of the cost. You use a $10 gift certificate. This expression represents the total cost of the meal. So this whole thing right here is the total cost. Your instructions are to simplify the expression, identify the units of each term, and the final units of the entire expression. So I've got 3c plus. Here, I've got two numbers that are being added together in parentheses. So I can combine those into 0.26 times 3c minus 10. Right? Before we do any addition or subtraction outside of parentheses, we have to take care of multiplication and division. So when I multiply these two things together, I end up with 0.78c. I bring the minus 10 down, and I bring the 3c down. I can combine 3c and 0.78c together. Get 3.78c minus 10. Okay? So, here's the easiest way to take care of this. In the word problem, it says you use a $10 gift certificate. So I know that this piece right here has the units of dollars. And in our exploration last week, we learned that in order to add and subtract units, or add and subtract things, they have to have the same units. So by default, this piece is dollars. And when we put everything together, we end up with dollars, which should have also been a clue because it tells you in the problem this expression represents the total cost of the meal. And how do we pay for things in this country? With dollars. Okay? This word problem you're going to try and complete on your own, in addition to the your turns that you are given at the end of your notes. So go ahead, give them a shot, check in with me when you're done.